Hello everyone, today we're going to be looking at the sulfonation of an aromatic compound. This is a quite simple reaction. The mechanism can get a little tricky, but yeah, the overall reaction is going to be what we call fuming H2SO4, hydrosulfuric acid. All that means is that there's SO3 lying around in there, and that's going to be an important reagent, as we'll see. Let's look at the properties of our main electrophile SO3. SO3, sulfur trioxide, right? It's important to know that oxygen is more electronegative. We all know that, right? It's going to pull electron density towards itself when compared to sulfur. Sulfur is less electronegative, and therefore, when it's bound 3 times, double bonded to a sulfur, it's pulling electron density away. It's stealing that from that sulfur, and oxygen's hogging it. We can explain this with orbital overlap, right, of the pi electrons here. Sulfur is a big fat atom with a big fat orbital as a result, right, because it's a higher energy orbital. Oxygen, on the other hand, is a very itty-bitty small orbital, and because of that, oxygen is going to hog more electron density, right? All right, and we know that because oxygen is more electronegative. Now, let's get into the mechanism. Alrighty, we're ready for the mechanism here. Let's take a look. So we have SO3 as our the start of the mechanism here. We need to prep this electrophile. So it's quite simple to start. We just take a lone pair from one of these oxygens, and it comes to the hydrogen. It's like, hey, you're a strong acid, and I'm an electrophile. So I'm just going to take one of your hydrogens. And we get the following compound. And hopefully you'll see something really scary and something that makes all chemistry students very sad, and that is an oxygen with a positive charge. What is oxygen? It's one of the most electronegative atoms, right, behind fluorine, right? So it hates positive charge. It's like, I hate you, positive charge. And as a result, the equilibrium here is heavily swayed in the reverse direction, but we'll see why the resulting one will make it not irreversible but happier to go forwards. Oxygen with a positive charge, how can we neutralize it? Well, we could go in the reverse and restore the SO3. We could also do a reaction if we were to, say, put an aromatic compound in here. Well, this pi bond here is going to reach out from our aromatic compound. We're going to use benzene for most of these reactions. It's going to come into this sulfur, and it's going to attach itself as such. And we're going to get the following compound. And that... I'm an artist, guys. Look at me. Oh, and I forgot to add one of the pi electrons are going to come out, just making a normal OH group. So we'll draw on those electrons right there. All right, and then we have a positive charge on the carbon. Right here on this carbon. So if we look at where the equilibrium will lie for this one, who likes a positive charge more, oxygen or carbon? Well, it's quite simple. Carbon would obviously take a positive charge over oxygen any day of the week. Any day of the week. It's like asking me, would you rather have a Pepsi or an Arnold Palmer? I'd rather have an Arnold Palmer every day. Pepsi's trash. All right. Pepsi's like my oxygen. I hate having a Pepsi. Oxygen hates having a positive charge, but carbon's okay with it. So hopefully my little tidbit there made sense at all. Right? So the aromatic compound attacks that sulfur center. That's pretty partially positive. Dumps some of those pi electrons onto the oxygen, and we have a neutral sulfur substituent there. But we do have our positive charge on this carbon. But it's not really all on that carbon, right? Remember, because this is the sigma complex, right? It's that resonance stabilized where that positive charge is felt here. It would be here and there as well. Alrighty. So quite simple. How do we neutralize this? Well, it's very similar to the halogenation that we saw. We just come here with our conjugate hydrosulfuric acid base, and it's going to take one of these hydrogens. It's like, hello, and those electrons are like, yippee, we're gonna make everything neutral, and this reaction's all happy, no charge, no nothing. We're so happy. Right, so we have our final product here, which is going to be a sulfonated product. And that's that. Okay, quite simple. Let's just go through the mechanism one more time so everything makes sense. And remember, this is acid catalyzed. So I'm going to write that here, acid catalyzed. And we're going to draw a smiley face too because we're happy today. Okay, SO3 reaches out to hydrosulfuric acid, steals a proton, and then oxygen gets a positive charge. It's like, no, I hate that. That's terrible. Screw you, man. So the aromatic compound reaches out to sulfur. Sulfur's like, okay, oxygen, you're neutral now. Calm down. All right, it attaches, but now we have a positive charge on a carbon on that once aromatic compound, forming a sigma complex. We neutralize that by taking our once deprotonated acid, that conjugate base, and we use that negative charge on the oxygen to steal back a hydrogen and give us our final product here. So sulfonation, quite simple. Alrighty, that was sulfonation there. Hopefully you guys enjoyed that video. If you did, drop a like, drop a comment if you have any questions, and meet us in our next episode. We're going to look at nitration.